This is Brother Cromer from the Math Department again, and I'll be continuing with Lesson 9, which is dealing with inference for one mean sigma known, or the population standard deviation known. This is really the intro to hypothesis testing, and so now we're going to get into how to for a hypothesis test, or testing one mean where the population standard deviation is known. Okay, so now let me just give you some introduction before we get into the how-tos. When the observed results are unlikely, assuming the null hypothesis is true, the result is what's called statistically significant, and if it's statistically significant, we reject the null hypothesis. Or in other words, if a sample mean has too many standard deviations from the mean stated in the null hypothesis, we reject the null hypothesis. And that is what is called an unusual value or a rare event. So say for instance we have something, if this is the null hypothesis here in the center, and we get something maybe over here or over here, that's what's called an unusual value or a rare event. Okay, so assuming the null hypothesis is true, if the probability of getting a sample mean is extreme, or more extreme than the one obtained is very small, then we reject the null hypothesis. And so how do we do this? First of all, we get what's called a p-value. Now this is what's introduced back in lesson 2, but the p-value is the probability of getting that sample mean or more extreme that was obtained, assuming or if the null hypothesis is true. And so what we compare the p-value to is what is called the level of significance. And what's the level of significance also equal to? It's also equal to, if you remember from the last video, the probability of committing a type 1 error. So we're going to compare our p-value really to the probability of committing a type 1 error. And so the p-value is smaller than alpha. This would be considered a rare event or an unusual event or an unusual value, and the null hypothesis would be rejected. Okay, and the little ditty that was given in the wiki or in the text, which is saying the p-value is low, reject the null, and that's a good way to remember it. Now, when we set our level of significance or our guidelines, we need to set that prior to our analysis. Okay, now before we do so, when it comes to rare events, we can have 3 different types of rare events or unusual events. If you remember back in the last video, there's 3 different types of alternative hypotheses. We can have something where the alternative is on the right side or on the left side, or we can have it to where it's not equal to. Okay, so now we have say for instance, if we have a right-sided test, if we have a rare event or unusual value that's on the right side, that would be somewhere in this over here on a right-sided test. If we have on a left-sided test, we'd have a result that's somewhere over here. That would be an unusual value. If it's a two-sided test, we could have it on both sides here. So anywhere in this region, given that the center is at the null hypothesis, those areas would be considered unusual values and that or rare events, and that would constitute rejecting the null hypothesis. Okay. Now, before we do any type of testing, we need to check some requirements or what the book or the video calls what the wiki or the online text calls assumptions. And there's 3 things we need to assume, and this is what we need to check. First of all, we need to assume that it's a simple random sample, that we know the population standard deviation, or either one of these conditions are satisfied. We have to know that the population is normally distributed, or the parent population is normally distributed, or we have a large enough sample size greater than 30. So this goes back to what we learned in lesson 7, that dealing with the distribution of sample means being approximately normal. That's why we did that, so we can do these tests that we're going to cover not just in this lesson, but in future lessons here in Unit 2. Okay, so let's go through. These are some steps in terms of how to calculate or do a hypothesis test after we get data. So first, or going through the process. So first we state the null and alternative hypotheses, and we need to determine the level of significance, and usually it's within the range of 0.01 and 0.1. The most common one in most industries is 0.05. Then what we do is compute a test statistic, and this is what's called the z-score, and this is what you've seen before going back to Unit 7. But now we're going to compute a z-score relative to the null hypothesis. Then we get a p-value, and you'll use the output to get the p-value. And then we come to the decision rule. We either reject the null hypothesis if the p-value is less than the level of significance, or we don't reject if the p-value is less than the level of significance. And then we state our conclusions, and there's 2 ways to state our conclusions. If we reject the null from step 4, then we have sufficient evidence to say that, and then we state the alternative hypothesis, whatever this is, in plain English. If we don't reject the null hypothesis, then we have insufficient evidence to say that, and then we state the alternative hypothesis in plain English. And so this is a blueprint in terms of how you could write the conclusion. Okay, so now what I want to do is go through a couple of examples. So when people smoke, the nicotine they absorb is converted into cotinine, which can be measured. Historically, the mean cotinine level of all smokers is equal to 200 micrograms per gram. You would like to see if it has decreased, so a simple random sample of 40 smokers has a mean cotinine level of 160. Assuming that the population standard deviation, or sigma, is known to be 119.5, use a level of significance of alpha equal to 0.05. So step one is, and this is what we covered in the last video, state the null and alternative hypotheses. So the null is that so historically, or the status quo is that the population mean is equal to 200 micrograms per gram. So, but you would like to see if it's decreased, so the alternative hypothesis is going to be less than, okay, or is that the population mean is less than 200. Step number two is calculate our test statistic, and this is, in essence, really a review of what we did in lesson 7. So where we take we take the sample mean that we got from our sample, which is 160 micrograms per gram, minus the null hypothesis, which is 200, divided by our population standard deviation, which is 119.5, divided by the square root of our sample size, which is 40. Okay. So now, when we solve for that, we get a z-score of negative 2.117. Okay. So now, so from here, what we do is we go get our p-value, and where we get our p-value is using the applet. So what we need to do here is that we need to shade to the left because we're worrying about less. The alternative is less than, and we type in our z-score, which is 2.117. And we press enter, and voila, there is our p-value. Okay. And so when we go, let me go back to the results here. Our p-value here is 0.017, which is less than our level of significance, which is 0.05. And so therefore we reject the null hypothesis. And we conclude that we have, because we rejected the null, p-values will reject the null, we have sufficient evidence to say that the mean cotinine level has decreased from 200 micrograms per gram. So I refer to the alternative hypothesis in the conclusions because we have sufficient evidence, because we rejected the null, that the mean cotinine level is less than 200 micrograms per gram. So let's go through one more example, and so what I want you to do is stop the recording throughout here. So here's a problem based on historical data obtained from Brother Bergstrom. The grade point GPA, the grade point average GPA of students from BYU, Idaho is known to have a mean of 3.15 and a population standard deviation of 0.68. We want to determine if the mean GPA is now different. So then I'm going to go to this next part here. A total of n is equal to 30 people were surveyed and asked to report their GPA from last semester. The mean of the GPAs in the sample was computed to be 3.263. So use alpha equal to 0.05 level of significance to test this claim. So stop the video and go through these 5 steps to see if you can come up with the right results. Okay, so the null hypothesis is that the mean is equal to 3.15 because that's the status quo. The alternative, we're looking to see if it's different, so we state the alternative hypothesis in this way. When we calculate the test statistic, we take the sample mean, which is 3.263, minus the null hypothesis, divided by the standard population standard deviation over the square root of our sample size, and we get a p-value of 0.91. Now, if you go to the applet, you should have gotten a p-value of 0.3628. And then the decision rule, since the p-value is greater than our level of significance, we do not reject the null hypothesis. So therefore, we have insufficient evidence to say that the mean GPA is different than 3.15. So just to check, just to be sure, just so you get this, if you had to shade both sides, and if you type in what the z-score was, 0.91, if we typed in 0.91 here, this is how you got your p-value, okay? And that is the last of the lesson 9 videos. And if you have any questions, please speak to your instructor.